So this is a presentation about beach stones, and in particular beach stones we call Omars and Yooperlites. Uh, Going after beach stones is a common activity for visitors to the Keweenaw. Here's a view of the beach at Gratiot River, and you can see it's a high energy beach because the energy of the waves has moved the sand away and created a pure deposit of cobbles and pebbles that you can look through. And it's quite a variety of things. Susan Robinson did a painting of all the different types of stones that you can find, and you can see the Jacobsville sandstone, you can see some amygdaloidal basalt, and you can see some light colored streaked fragments, which are what we call aliens. They're rocks that came from very far away and were probably dropped by a glacier from someplace north in Canada. So here are a couple of beaches which contain fragments that are mostly local. The upper one is a Jacobsville beach below a Jacobsville cliff, and you can see some of the red particles with white spots in it. And below is a beach from near Scoville Point on Isle Royal, which is mainly made up of pegmatite fragments from the lava flows, the center part of the lava flows that we find. So it's again a local rock. It didn't come from far away. But most of the beaches that you'll go to will be a mixture, a vast mixture, and which probably includes several local rocks and maybe as many as 100 alien species that are present. And I call them species, but I mean different kinds of rocks. And so now, back in the 1870s, a man named Robert Bell discovered some distinctive rocks in Canada that were transported by glaciers, and these he eventually worked their way to a man named Victor Prest, whose name is written on this rock, and he started to call these Omars after he did investigation of where they might have come from. So Omars are widely known, and people have found them. They thought they were candle holders or had some kind of fairy relationship to ancient people, that they might have been sculpted by people and not natural materials. But Victor Prest realized that they were, in fact, natural materials. This is a cover page, really, from the article that he wrote about Omars, which really told the story of glacial history and the fact that the Omars were carried a long way, hundreds of miles from their source, and that the rock that they were carried in, although it looks like a basalt, is technically a sandstone, which is made up of basaltic fragments, which is why it looks like a basalt. And so these things are called greywackies. And here's a detail of some Omars that were found in Manitoba. They were traced all the way across Manitoba, so the people in Manitoba learned that they were carried to the south and were dropped at various places along the road. And they contain these holes, and sometimes the holes are weathered out, especially if they've bounced along at a beach, because they're softer than the greywacky surrounding them. They are easier to erode. but they're a kind of something that we call concretions. And concretions form in the interior of, they begin to form in the interior of the Omars, and they start from a central point where a cyanobacteria colony begins to grow, and it gets larger and larger and surrounds itself kind of like the layers of an onion and cements the spaces between the grains of basalt. And this rock starts out with quite an open space because a lot of the basalt particles are angular, and so there's a lot of space in between, and they form concretions. If you want to see and put your hands on Omars, go to the third floor of the Dow building in the north side elevator, and there's an exhibit of these where you can put your hands on these wonderful rocks. We know how they formed, and they formed in a deposit like ones that are forming now in the southern part of Iceland, where during eruptions under the ice, fragments of basalt build outward toward the ocean in the form of sandy, deltaic sorts of deposits. And you can see how the rivers wind around on top of each other and form a gravel, which contains ice, of course, in it, and reaches all the way to the ocean and goes beyond. And so if you take the road around the southern edge of Iceland, you'll cross these great sand dunes. And so this is the kind of environment where the rocks that Omars came from were found. But where were they found? To explore that, we have to refer to a man named Robert Flaherty. Robert Flaherty was a Yooper. He was from Iron Mountain. And during his life, he was born in the 1880s, and during his life he became an early filmmaker who made the first feature-length documentary, a kind of anthropological documentary, which was world famous, called Nanook of the North. And this made him into a big reputation. Here's a poster from the movie. It's actually still used in some anthropology classes. It's a classic, and it described life in a place in the northern region of Canada, a part of something called Nunavut. And Nunavut is this area in northern Canada, but it extends to the islands within the Hudson's Bay. And this red spot that you see here is the Belcher Islands. And the Belcher Islands is a geologist's dream. I say this because the rocks here have been spectacularly folded and turned to a vertical shape so that you can, these are Google Earth views of what it looks like, and this is a drone view of the different kinds of layers. And so there's just layer after layer of different kinds of formations, including formations that were basaltic greywackies, and like the formation where it was found. The formation is named after a man named Omar Look, and he worked with Flaherty on Nanook of the North, but he also built a reputation as a guide in the Belcher Islands and worked with geologists who flocked to the area to explore all those different layers of rocks and see what the geologic riches might be. So here's a map that shows the distance, 725 miles from the Keweenaw Peninsula to the Belcher Islands. And here again are some images of different kinds of Omars, spectacular sort of rock that has been found many, many places. Again, a view of the amazing occurrence where you have these steeply dipping folded rocks and then a very flat glacial surface smoothed out over the top. So just an ideal situation for having a lot of different kinds of rocks and very well exposed. And this salmon color that you see in the cross-sectional sorts of rocks, like this area here and this area here, is the Omar Formation, where these basaltic greywackies come from. And the next slide shows how moraines form around lobes of the glacial cover, and it's in these moraines, these still stand lobate moraines, where Omars are concentrated, and that's one reason why we find it along the north shore of the Keweenaw, because that is the position of where lobes formed. Now, this panel shows what the Omar Formation looks like on the Belcher Islands, and you can see here with the spots associated with it, and the analogy with the things found further to the south, and the position of lobes in various locations where Omars are especially abundant, and some of Robin Mueller's territory near Misery Bay, where there are a bunch of Omars to be collected. A detail of the Omar Formation shows lots of features which we call dewatering features. They were very rich in water, like you would expect for things running out underneath a glacier, and when they get compact, it squeezes the water out of them, and it makes these formations that occur in addition to concretions. Just to remind you about the age, one coincidence about this is that the Omar Formation is almost the same age as the lavas on the Portage Lake, about beginning just a bit after 1.2 billion years ago. This is the whole timeline of the Earth, and the origin of most life, of course, occurs after this. But we did have cyanobacteria. Well, now let's go to another rock type. I'm going to refer
when
to...
rock hunter Eric Rentemacki was combing the beach one night near Sault Ste. Marie, he made an interesting discovery.
I was trying to figure out a way that was easier to find Lake Superior agates on Lake Superior. So I bought this black light flashlight to go out at night and try to find agates.
Eric is a third-generation rockhound, and what he found would have an impact on the Upper Peninsula, the mineralogy community, and tourism.
I found these, had no clue what I had found. Went home.
So, just to remind you where you can find this and a wide variety of other communications about Yooperlites on the web, there's the web address for you. While there are dozens of these, and others are really excellent, my favorite is this one, which is done by a person.
Thanks to 41 Northcote for supporting the series. Hey there, welcome to the beach. It's very bright and a bit windy, But that's Lake Superior in July for you. The first time I ever came up to Michigan's Upper Peninsula and Lake Superior, I was delighted at how many good rocks you can find on the beach. And shortly after I moved up here, I learned that one of the coolest rocks of them all is this. If you hit this thing with the right kind of UV flashlight, similar to the black lights you might find at your local laser tag place, you get something amazing. These rocks go by many names.
So this is Alexis Dahl. She's, I think, one of the best communicators of geostories in the whole area. And she has many wonderful videos, but this one is especially nice and goes into a lot of the popular aspects of Yooperlites. Now I want to go to this Seaman Museum to show you again some more details and to remind you that there's a beautiful exhibit of this put together by Bob Barron and others that shows Yooperlites. Here's a example of them in plain light, and this is what they look like in the black light, the long wave black light. And you can see that not only do they show yellow to orange fluorescence, but they also show a remarkable variety of patterns. Here's another example of this, and so you can see these for yourself in the Seaman Museum. And you can also go to rock shops. This is a website from Johnny Gladstone's website showing the different varieties of textures that occur within the Yooperlites. So many people want to collect all of these kinds of textures. These are not geologic names for them. These are commercial names for them. And this is the man, John Dean, who kind of coined the terminology for them. But all over the web, you can buy Yooperlites now. But they also can still be readily found on the beaches. One example of this use of Yooperlites comes from this man, a guy named Brian Yassetti. He's a Zuni Indian, and this shows the different lighting conditions, and so he's made a decorative sculpted item. You can buy, as I said, Yooperlites in a variety of places. Here's a local source, and I didn't try to find all of them. Why do we have yellow glowing minerals? It's because of a mineral called sodalite, a pretty rare mineral, and we didn't know it existed around Lake Superior until Eric Rintamaki discovered it. And so we think it comes from a place to the north, and I'll show you where it is. But it's a rock called syenite, formed at the same time as the Mid-Continent Rift. So it's a mineral. This shows the chemical formula and things about it. And it also shows the name of the place it came from, something called the Coldwell Alkaline Complex in Ontario. That's on the north shore of Lake Superior. I'll show you where it is on a map in a minute here. But the sodalite that's at the Coldwell Complex also occurs in a variety called hackmanite. And hackmanite has a special quality called tenebrescence. So fluorescence happens when electrons are kind of moved around and they begin cascading and emitting photons, and which is triggered by the ultraviolet light. But Hackmanite is a variety in which the color changes at various times in illumination. So here are the stages where you start out with a mineral that looks white in color. You turn off the room lights and turn on your black light, and it looks yellow to orange. And then you turn off the black light, still in the dark. You'll see a dull bluish mineral, and then finally a brighter greenish mineral. And this is a variety of sodalite, which we call Hackmanite, and that does occur within the varieties of sodalite that are found in Yooperlites. Well, here's the location of the Coldwell Complex on the northern edge of Lake Superior. And so if you take the rim road around the lake, you'll go right over it. Here's where the road traverses through it. This is a blow up of the region. You can see the different colors here, which show the different kinds of rocks that are nepheline cyanites, and that particular rock type, which often contains sodalite. And so the sodalites were dragged by the glacier from this site all the way across Lake Superior to the Keweenaw and other places in the UP. Next, give you some background on where you can get a good flashlight. Not any blacklight flashlight is as good as these are. These are varieties that you can get at the Seaman Museum. They've tested them all. And the best one, which gives you the brightest long wave illumination so that it works even in the daytime, costs $79. A little steep, but if you're really interested in this, you need to have a good blacklight flashlight. And what you can notice about it is the good one will work in the daytime, so that you can see that the Yooperlite glows even in the daytime. And so the other thing you can see at the museum is a tremendous display of fluorescent minerals, not just Yooperlites, but things from other places. Like this. This is a picture from New Jersey, a place called the Franklin deposit, where there's big rocks, fragments of minerals that all fluorescent different kinds of colors. And so it'll give you all the information that you need about it. At the Seaman Museum, we don't have rocks as big as this one shown in this picture, but there are beautiful examples that show all the varieties of colors. So you should go and enjoy. Well, what's the next thing about looking at beach rocks? What other kinds are there? There's one that people find it's possibly as common as agates are. It's a type of rock called a unakite. A unakite is a red and green rock with also some white patches, which is quartz. It's an altered granite, kind of a metamorphic rock that has this distinctive color formation. And it occurs various places on Earth, clearly somewhere in Canada to the north, produce these rocks, and they are moved to the south, so they occur on Keweenaw beaches. But the name comes from North Carolina and from the Cherokee tribe. In the Cherokee, there's some mountains called the Unica Mountains where these rocks occur. And Unica in Cherokee means white. And why would they be called white with this kind of coloration? Well, it's because the Unica Mountains was the site of abundant chestnut trees, which had white blossoms in part of the year. And so the whole sides and tops of the Unica Mountains were marked by these white flowers. And so the rocks were named after the white flowered mountains. Anyway, an interesting thing, we need to find the source of unikites in Canada that relates to the rocks that we find in the Keweenaw. There are many other types of beach stones. Here are some ophites. These are local beach stones. I found these at Beta Grease, where they're very close to lava flows that have ophitic texture. So they haven't moved very far from their source. Here are some greenstones, which can be found in beach rocks. Maybe harder and harder to find now than they used to be, but they occur as filling of amygdaloids in rocks, and most people that use them in jewelry get them out of these rocks. They chip them out of these rocks and then roll them afterwards, and so they aren't collected as often as beach stones anymore, but they used to be. Agates, of course, are still quite common in beach stones, and Lake Superior agates are world famous, and still highly prized examples are found, sometimes with native copper rings in them. Well, that's the end of this. I hope you learned something new and of interest to you about beach stones. Have a good time out there.